Welcome to this presentation. Today, Stéphane and I, Brian, we're going to talk to you and describe how you can hit the refresh button on your Spring Boot application. So we'll use an existing Spring Boot application, we'll show you how it works, and we'll upgrade it and introduce some nice changes with the version upgrades we'll do along the way.
And because that's the end of the day, everything is going to be on slides, so that you can easily follow and
Liar.
okay. Whatever.
That was it.
I might regret doing this if the if the demo don't work. Okay. So what do we have here? We have an app. Let's try to start it, maybe.
Yeah, let's go. It's called the Ops Status app.
Okay.
And yeah, when you start the application, obviously it doesn't work because you have a connection refused.
Mm-hmm.
So let's say we're new to this app, right?
Yeah, there must be a README saying what you should do, right?
Okay, you need to do something with, okay.
Run Postgres and what? What?
And good luck with that, yeah. Okay, so this is basically your friendly wiki page when you're starting a new project or a new team, and this is how you get to know how you need to install things on your local laptop to get the application running and so on. So we'll start with that, and there you go. You have the connection information in the application.properties. So we need a Postgres instance running on our laptop.
Okay,
so we'll do just that.
Let's go with like a command we found on Stack Overflow, and then put that in some text file to remember it. Not like we should put it in the README. Nobody reads them anyway. Yeah. So let's start again. That's better.
It works.
Yeah, it looks like we have a warning here.
Okay. Warning.
So always read the warnings, right? Because when you upgrade, the warnings become something like doesn't work and you don't know why. So it says, it says like our Postgres version is a bit too recent. Latest version is 14, and by the way, this application is still using 2.7. We're still using Spring Boot 2.7. No. Okay. We have supporter for the early migration. That's good. Okay, so let's have a look to the app. Okay. So
it's a bit old school, but that's on purpose.
But it says that everything is down there. It's strange, right? Something should be at least up. Right, okay, let's have a look. I don't know. Do you know? There must be like something.
There's a script folder up there.
Script folder, let's see. Run mocks. Okay, let's do that.
Okay, maybe we need to do that.
Okay.
And then we can have a proper look at what the actual application does, maybe.
There we go.
Yeah, okay.
Okay.
So we have what? It's like a status page for our gaming platform where you can see the components of our infrastructure. So our gaming servers, load balancers, and so on. We check the availability status of each, and we check the date, and then we have some incidents, ongoing or not, scheduled maintenance, and past incidents, and so on. So this is displaying, basically operational status for our own platform, and we even have some API to retrieve the incidents if you want to have a look. But that's a basic, not too very complex application.
Nope. We also have like, let's have a look. We also have like something that checks for components and just making sure they're still up, update the availability if necessary. That's the thing that's calling that mock server we have over there. So the getting started experience, not that great. It's running also on an old Spring Boot version, so let's try to fix that. So let's go.
And I think we should look at the application properties as well, because I saw some things earlier. What are those threads configuration?
Right. Yeah, okay, so for the purpose of this app, we pretend that it's like high traffic. You have like a lot of requests, so we've increased the pooling of the web server a bit, that we can handle more concurrent requests. And that application behind the scene is doing a lot of scheduling tasks just to make sure that components stay up to date. And so to make sure that we don't end up with pool starvation, we've increased the pool a little bit. The default pool size that Spring Boot gives you is 10 in both cases, so we've increased that a bit.
Okay.
Should we upgrade?
Let's start it. Yeah.
Okay. So to upgrade, what I'm doing right is I'm just like putting the latest version over here. That's what you need to do.
Straight away.
Yeah, just you upgrade your old stack. What could possibly happen?
10 versions in a row.
Yeah. No, that's
nah. Maybe yeah. Usually, what we try to do is to have some decent migration guides and doing them one by one. So minor version or major than minors is usually easier because that's how you don't end up with multiple problems conflicting with each other and you don't know where the migration went wrong. So usually if you take step by step, the upgrade path is way easier. So let's do 3.0 first.
Yeah. Also, something else that we were looking quickly is like making sure you don't have any potentially dangerous warnings in the logs. Checking in application properties, you're not using a key that's deprecated, because when you do so and you upgrade, the key that's deprecated and still works will become potentially unavailable, and your app, the behavior of your app will change. So whenever you have like something that's deprecated or something that basically gives you a warning, it's better to fix it before the upgrade. Also, you can see that this app is not using Java 8. Sorry to disappoint. It's already using Java 17, so that we don't have to bring that back as part of the upgrade. So let's start with 13.
Yep.
Yeah, there we go. Okay, so let's upgrade to Spring Boot 3. And yeah, we have like some issues. You can see that that Spring Data repositories, some methods have disappeared. So that's really one of the benefits you get from upgrading one feature release at a time. That for 3.0 there's a big bag of things depending on the size of the application and the number of features that you're using. But once you've upgraded to 3.0, then the rest should be smooth. So if you go to the migration guide for 3.0, you'll find some links to Spring Data, and they will state that there was some restructuring into the repository interface. So let's have a look to that.
So we were extending paging repository, which is now just extending repository and not CRUD anymore. So we're missing the methods that we're using. So if we extend that one to have both paging, pagination, and CRUD,
yep,
we should be good.
And the same for this one.
Same thing for the other one.
So CRUD repository. So essentially, the reason why they've changed this is to give better composability. And if you opt in for certain feature of a Spring Data repo, you don't get features that you don't need. It really helps you to reduce the surface of the API. Okay, so let's try to build this. If I can type.
Okay, we have a decent test suite, including a few integration tests, so it's all good for now. So we can go to the next step, which is 3.19. Okay. So not very exciting so far.
All right, let's try.
And same. And we can go to 3.2.3 now. All right. So it's still doing some decent things. We're using Actuator and Spring Data JDBC, Flyway, and REST template and web in various. And we're using also observability with metrics as of 3.0. So we're using quite a few things, and we only had so far the repository thing that we needed to upgrade. Otherwise, the test suite and the drivers are working well with our setup.
Yeah, and the warning is gone. The warning is gone because the Postgres database was too recent for an older Spring Boot release. By upgrading, you also get the Flyway release that actually works with that PostgreSQL version. So the warning is gone now, which is good.
But which version of Java are we using right now?
17.
17. But now now we're on 3x, we can do more. Like we
can do more, yeah. And so okay, let's try. The new LTS is 21, so
okay.
Let's try that.
And now, and because we have some performance profile with the threading and the threading configuration that we have, now we can consider maybe virtual threads and see how we can leverage it in our own application, right?
Yep. So let's have a look maybe to the application as it is now, running on 21. You see, like upgrading to the new LTS also brings like improvements on Java itself, so potentially a lower latency, better memory management. So there is a lot of benefit in doing that. Let's have a look to the app that we have. So 21 unmodified. Did I write JConsole right? Yeah, I did. Oh, okay, it's there.
Okay.
Okay, boy.
So now choose the application, that one, and then we can have the graphs and see, especially our threads ongoing.
That's what we want to focus on, because we're going to show you how you can benefit from virtual threads. So what you can see here is on the left hand side, you have a number of scheduling threads. They're increasing every time a new task is scheduled because it didn't reach the end of the pool. So the default behavior is to create those threads so that they're ready if new incoming tasks are being requested, rather than reusing the only one that we have. So that's what you see here increasing. At some point it will stop because it will have reached the pool. If we look at it's a bit small for you, but you have the HTTP executors on the left now with like 20 threads waiting to handle incoming HTTP requests.
But now in our case, we have some, we're doing some checks with some external services, and with the runtime profile of our application, maybe it's interesting to spend less memory on threads doing not so much or being blocked, and try to leverage the virtual threads feature and see how that goes for our application.
So we're like at 60 something threads for this app. Let's opt in for virtual threads. So just because you use Java 21 doesn't mean that Spring Boot does some automagic thing. It will not opt in for virtual threads because it's like a decision you have to make. Potentially there are some things that you need to consider that we will discuss in a minute, but let's maybe focus on the demo now. True. So there is a single property that opts-in for virtual threads, and everything that Spring Boot auto-configures will be adapted automatically. So if we go back to the app, it's like, the same app as before. Let's see, oops, status. That's because it's the old one. Boo. Oh, boy.
So yeah, there are quite a few things to consider with virtual threads. It's not a given. You don't necessarily need to opt in, like you said, and that's why the value for the configuration properties falls by default. It depends on the profile of your application. It depends on the kind of traffic you're getting. It depends on how much memory is being used and what's the bottleneck at some point. But here, what do we have right now? We are
yeah, 40 something, and you can see also that the thread for the scheduling and the thread for HTTP, they're gone now because Spring Boot automatically adapt your choice of using virtual threads, and they don't doesn't anymore create the thread pools that we were showcasing previously. So very easy to opt in. Then you can make some test with it, and that can bring also nice improvements for your application depending on your use cases.
So if you have a lot of concurrent work with a lot of blocking I/O, that can be helpful because you will spend less memory on the actual platform threads, and you'll be more. It'll be less about thread hopping and more about CPU, actual CPU usage. But in some cases, while discussing with customers and the community, we also see that in some cases when you switch that on and you run your usual test or performance test with your application, what you might see is a different bottleneck. So previously, some thread pools, they were acting as bottlenecks, natural bottlenecks for connections, incoming or outgoing. And when you have that, you're basically opting in for an infinite amount of threads. And when doing that, you might find another bottleneck, which might be memory, maybe if your threads are carrying a lot of data. If you're, for example, deserializing a lot of JSON and holding that into memory for quite some time, then if you're increasing concurrency, then you'll have some memory issues because of this, or it might be some other connection pool down the line. So it's interesting to opt in, try things out, but you also need to think about how the performance profile of your application changes and if that's really a good fit for your app.
So with the virtual threads option in Spring Boot 3, you essentially get a lean servlet-based API with this new mechanism. Also for HTTP access. Right now we do have a client, so maybe let's have a look to that. If I find yeah, there we go. That's the client that's being used to issue requests to the remote service to verify if a given component is actually available or not. We can see there's a bit of like setup there for the REST template, setting the base URI and then some headers. So you can see there's a bit of setup there. So maybe a question: who's actually using the REST template right now in their app?
Yeah, quite a few hands.
Much? Okay.
Right.
For those who are using it, have you seen a note in the documentation about a maintenance mode regarding REST template?
Yeah.
There's a few.
A few, yeah.
Okay, so that made the community a bit confused because they were like, okay, I have a REST template, it works, so why are you saying this? That note was added at the time where the web client was introduced as a new way to access remote services with Spring. And the fact that the REST template API is 20 years old now, even a bit more than that. So it's really hard for us to make it look shiny and 2024 with the baggage that it brings. But the benefits are definitely there. So we wanted to do something about it. And in this release, actually, I think, 3.2, we've introduced a new client based on REST template so that you get the modern feel of it while keeping like basically everything that you know about and without the reactor dependency. So it's using a blocking model. So let's have a look to this new client now. Before we do, we have tests for this. I wanted to quickly show you. They're using the RestClient test, slice test from Spring Boot. So essentially what it does is it's only focusing on HTTP client test. It configures a mock server that link basically to your client, and then you can configure expectation. The client behind the scenes is not issuing requests to the outside, but using through the mock, and then you can assert that the request matched the expectation, etc. Nothing new, it's something that exists for a long time. I just wanted to show you that before we switch to the new client.
So the new client won't bring like new facilities. It won't support advanced streaming like web client does because you need some specific API to really handle streaming. Here we're using the same infrastructure underneath, which support the same clients that we already support with REST template. Here we're just bringing a like more modern API that's more in line with the functional parts of Java and what you're more used to do these days. So as you can see, you can ditch the HTTP headers object and like the cumbersome entity to be written. It's an actual DSL where you go get URI and you can write the accept header in line. Same thing for the authorization custom header that we're doing for the bearer token, and then we can decide whether we want to get the entity or the actual object right away. So it's more of a DSL and less REST template, which was overusing the like method variants and overridden methods all the way, which could be a bit confusing. So now it's more directed for you, and yeah, as you can see, it's a drop-in replacement for what you got. Um,
So if you have like invested a lot into a REST template, you may have like a complex setup with like converters and default behavior and whatnot. The REST client is really not a new client, as Brian explained. It's really an interface on top of the existing facility. So one way to create the REST client is simply to specify the REST template that you want to use to the REST client, which is what we have here. So it's like calling create with an existing REST template. But we can also, if you choose to do so, or if you're like starting from scratch and you don't want to keep any reference to REST template for whatever reason, you can also configure the REST client with its own like builder mechanism, which is what we are going to do now.
And this really helps with the migration, because you can only change the API so that it's easier, and like you'll like to work with it without changing the underlying infrastructure. Because what we see often is like when you change the underlying client, if you're using HTTP components or the JDK one, and you switch inadvertently, that can have some unintended consequences, because all those clients, the client libraries, they have very subtle, sometimes difference when it comes to interpreting the server responses with headers and content length and whatnot. So here, that's a way to use a more modern client without disrupting your application or having to rerun like thorough tests.
And the Spring Boot support you get is in PAR, right? So if you used to inject a REST template builder into your component to get the auto-configured mechanism of Spring Boot, then augment it to build a REST template, you get the exact same mechanism with RestClient. So you can see here in that bean, I've changed the signature. Spring Boot will react automatically, inject a RestClient builder that has the auto-configuration applied to it. And then you can do any customizations that you want to apply to it. There's also one use in my test here. Let's change that. Go to builder. And run the test again, and then we're back on our feet without any reference to REST template.
So with that upgrade, we've already done something for the performance profile of our app. We've improved a bit our lives with REST client instead of REST template without breaking anything in our app. And now maybe it's time to consider how we could make the onboarding experience for new developers in our team a bit better than what we have in the README, and finding out about that mock thing that we need to take care of. Maybe we can do something about this.
Right. So we didn't actually, I forgot to show you, if we start from scratch without any services running and we run the test. Okay, let me switch to Java 21 now, otherwise it will fail. Let's make sure it runs the test there. We can see the test works, right, without the PostgreSQL database. So there must be something that was done to make the testing experience available without this extra dependency. The developers, they probably chose to run the test against a different database that's easier to set up and require the PostgreSQL database for running the app for whatever reason they have in mind. So if we look at the setup that we have now, there's actually two schema that we handle at the moment. As you've probably guessed, the tests are running with an embedded database. It's H2 in this case. So we have a schema for H2, a schema for PostgreSQL. And if you wonder how that works, you can, in Spring Boot, you can provide a placeholder in the flyway locations, and then there is going to be replaced by the actual database that's being configured. That's how you switch from one schema to the next based on how you start the app.
But that can be tricky, right? Because like the databases, they have some very different behavior sometime, or I don't know about you, but the syntax difference between H2 or Postgres or whatever, it can be hard to maintain. And in this case, we're actually maintaining two different sets of migration scripts because differences. So maybe it's time we do something about that maintenance burden so that we use actually the database in development and in tests that we'll use in production.
Okay, so I'm basically updating the README to state that they should start Postgres to run the test, right? That's what you mean? Okay, let me try to do that. Okay, right? You need, let's say you need Java 21 and Docker. No?
Really?
No? Okay.
It's even worse.
All right. So
what did you try when you first tried? You just clicked the play button, like the run button for your app.
yeah, it failed.
Yeah. Can we make it work though?
Oh. Ah, okay, I see what you mean. Okay, let's maybe start with the test first.
Yeah, we'll start with the test. Let's make the test run with the real database first.
Okay.
And we'll see about having a proper experience
So
after.
who heard about Testcontainers? A lot of people. Okay, good. So this is not new. So we're talking about, you know, the new and shiny and the reboot, but that's also available for quite some time. So if you're still on Spring Boot 2.7, but you shouldn't, you can use that trick, not to the extent that we are going to show you. So there's a little bit of like carrot of upgrading. So let's see what you can do now if you're still running with a version you're not supposed to. Right, so I've added like 2 dependencies which basically bring Testcontainers JUnit 5 support and the PostgreSQL support, which essentially is going to be to bring the container abstraction for Postgres. If I go to one of my tests that uses the database, so we have 2 at the moment. You can see it's using data JDBC test, which is a slice that only configures the infrastructure that's related to data access. I can say, okay, I want to also use Testcontainers and disable the test if Docker is not around. And then I want to create a container, right? So I want to make sure that some containers is starting as part of the test. And the thing that you can do now is this, if you don't know about it. So essentially what it does, it's like linking the container that was started before the test actually runs with whatever configuration that Spring Boot expects to be able to bind to it. So in this case, that's the usual like data source properties that you that actually we are also configuring in the application properties, as you've seen. One more thing, and I want to talk about this because that's really something that's interesting, is the preparing a live demo effect. Do you know about it? Preparing for a live demo effect has one outcome that's 100% true. You'll find issues. And you'll report those issues and have like interesting conversation with your teammates. So one of them, the reason why I want to mention this is I have to do this now and tell Spring Boot, don't replace the database with an embedded database, because that's the default behavior that you get with data JDBC test. So I did raise that with my teammates saying, hey, you know, that sucks, right? Because Testcontainers configure, etc., etc. And my colleague actually said, you're right. And he sent me a link to a GitHub issues, and that's an issue actually raised last year. And I forgot about it. So anyway, you have to do that, but we'll get that fixed so that you don't have to. If we start the app now, the test, sorry, that should do something different. So you can see it's like connecting to Docker, downloading the PostgreSQL image if it has to, and do the binding, right? So it's not using H2 anymore.
So we won't do it right now, but in theory, you can get rid of the H2 migration script. You can just rely on one single migration script for PostgreSQL database. And then you can migrate all of your tests for the container and the binding parts that we did.
Actually, I'm doing this now so that we can do this, exactly what you explained. So this is the other test that uses H2. Should be good. Okay. Then what we can do now is ditch H2 over here. We can also move the script back to its original location. Move H2.
Delete the rest.
delete
and
this.
the
So
properties thing.
it's a lot of like customizations, right? And if I go back here and test, don't mind the clean. I'm a Maven user.
It's a habit.
Yeah, that works. So the tests are running now, even though H2 is gone. It's like something like takes care of bringing the PostgreSQL database for you. But you said that, yeah, okay, so let's start the app.
Yeah, yeah.
That's the most interesting part, right?
But
Yeah.
same thing for the app. We're still needing.
Yeah, of
that
course. That doesn't
connection.
fix itself. So, I mean, yeah, sure. I mean, we can fix that by being a bit more friendly and providing a Docker Compose file. That's what you had in mind?
Yeah,
And then
because
you do Docker Compose up in the shell and
that's what people would do in the
Yeah.
team. Some people, some team member already do that, right? Because it's
Yep.
easier than firing up the containers one by one. But then it'd be nice if that one is not committed to the repository, to the Git repo, not just for show, but to do actually something.
Right. Okay, so something that you don't get in a version you're not supposed to use is Docker Compose support in Spring Boot. So how does that work? There is a new dependency you can add. It's really used for local development.
Yeah.
And what it does, it will inspect your project configuration, find out about Docker Compose config, and react to it. So if the services have been started already, it will leave it alone. But if it hasn't, like in my case, it will take care of it and start the application for you. So the application is starting now. So we'll probably get some different content because it's a different database. But you get the nice thing of actually being able to run the app. You can also do that on the command line, of course, and it will do the same thing. So you can remove all that stuff and be happy, right?
So just run.
Yeah, you do that. I think I made a mistake here. It's a little bit, you need to be very cautious about that stuff. So, okay, so that's the README now. And as long as you have Docker and a JDK, it will make sure to self-install whatever is needed for the app to run.
Yeah, it knows about how to bind things automatically to the right properties for well-known Docker images.
Right.
But you can also tag them to let Spring Boot know that this is, I don't know, a database, whatnot. So you can go already a long way with the basics.
Okay, so let's maybe improve our test. Let's go back to it.
Yeah, the binding part with the dynamic property source, maybe that's something that we don't need to repeat all the time.
Yeah, we have to know a lot about that thing, and also you have to know about the properties. We're showing like the obvious one with a database, but think about you using MongoDB or Neo4j or Couchbase or whatever. Then you have to remember how to set those properties, hard code that in your tests. It's a bit annoying. So let's try to fix it.
I mean, it works in development mode, right?
It did, yeah. So maybe we can do something here too. What am I typing here? Okay, so let's take this one, and you guessed it, if you didn't yet. There's a Spring Boot Testcontainers module. Let's try to add that. Happy. Okay. Then it does essentially it does what Brian explained with the Docker Compose thing, right? Where you look at a container definition, you realize, oh, that's a database. Okay, I know it's a database, so I know which property that Spring Boot will need. I will ask the container about those properties. I will set the configuration keys that I know are necessary for Spring Boot to bind to that service and do that for you. Same thing happens here. We don't do that the same way for Docker because it's like, in a test scenario, it might be your own decision of what you want to bind and how you want to bind it. So adding a service connection is essentially asking Spring Boot, bind to this, make sure that the test is actually going to connect to the service that this container starts.
So now we're better with the getting started experience for new team members. For our tests, we're actually testing and running locally against the right database. We did some improvements, but then again, we have some colleagues saying that one of the problems we have right now in production is that we are from some time generating new certificates in
Right.
production, rotating them,
Mhm.
and it's a bit of a hassle to manage that. So how can we improve this?
So in Spring Boot 3, if you've missed that using SSL or TLS, I highly recommend you looking at it. It's the notion of SSL bundle. So let's have a look to what an SSL bundle is. It's something that you can configure with a well-known name. Give it like, whatever the settings of the SSL bundle you need. In this case, it's using certificates that are located for demo purposes at the root of the project. And you can see the reload on update thing, which we will demo in a minute. But essentially, the key is once you've configured a bundle with a well-known name, then you can go into anything that Spring Boot auto-configures with SSL support, and rather than having to repeat that again, you can just give the name of the bundle and we'll link things together for you.
And FYI, you don't necessarily need to use the JDK format for certificates. You can use the PEM format here, which is the usual one when you're using OpenSSL. And here for our own server, we'll use the example-org bundle that we described earlier, and we will reload them when updated live in production. So if you run the application...
Yeah, not the test, I know.
We've switched to port
84043.
Yep. It should be HTTPS and so on. It's a self-signed one, so it won't work in our browser for real, but we can use curl to verify that it's a certain certificate. We can rotate that actual certificate, and then we can check that the certificate signature changed. So here we're like HMZ something.
Okay.
That's what we have right now with our connection. We have a script that just generates a new certificate and that overwrites it. You usually wait a few seconds for it to be reloaded. You'll see a message in the console stating that the Tomcat connector restarted. That's it. And now if you recheck again, you'll see that it's not the same certificate anymore. So what it does, it's changing certificate, but it's not killing existing connections. So only new connections will be dispatched with that new certificate. So you can run that live in production and it won't create issues for your users.
Okay, so next up is talking about observability. As you know, Spring Boot 3 was a major new release that has two themes that were like basically touching everything in Spring. The native support with GraalVM. The other one was unified observability and also namely bringing a story that's more complete. If you're using Spring Boot 2, you know that if you want to use distributed tracing, you need to use different tools, a different project. So the idea with 3 was to rationalize everything and make sure that the developer experience is a bit more consistent.
So we're covering as of 3.0, we're covering all the observations for HTTP clients, servers, and data, and whatnot. We're covering a lot, but we're adding more on the way as well. And as of Spring Boot 3.2, we are also observing, which is very useful in our case, we're observing all the @schedule methods. And because those tend to happen a bit like out of band, we sometimes don't know what they do. We sometimes don't know how long they take and what happens and how that connects with your entire infrastructure. So in our case, we're interested to see the @schedule method that runs every 5 seconds and that checks for all of our components. What does it do? How long it takes? And what's happening basically. So here with the observability platform that we have here, we're just collecting traces with Zipkin. We can see that we're getting the root observation, which is the task that gives you the actual code namespace, which is the class where the thing happens. Then there's the name of the function, which is the name of the method. And then in the trace, you'll see here that we're getting all the components from the database and looping over them and sending HTTP requests to those components to check for their status. And in the trace, that's basically what we're seeing. We're seeing some of those checks are quite quick. and we can see where it goes, the URL where it goes, the status, what kind of URI it was checking. And one is a bit longer. It took 2 seconds. And because that was basically a long 503 that we got in response. So maybe with that information in mind, if we've got more components or whatnot, maybe we can decide that we should lower the timeout or that we should treat things differently. But it gives you way more insights into what your application is doing, and you get actual traces that span your entire stack of services, which is super useful when you are looking into issues or trying to improve your operations.
So we will share the link with the repo, which is still private, by the way. So we'll make it public and share it with you. Again, we built on what we've been showcasing previously. So if you look at the compose file, rather than just Postgres, you get like Prometheus and Grafana and Zipkin configured like with settings for development environment. So same thing, the README hasn't changed. You just like invoke the same command and it will span those services so that you can easily interact with the demo application.
So we've got 5 minutes left. 5 minutes left. Maybe we can show something that we're working on right now.
Yeah, and yet another funny story is like we're going to show you something that actually is not yet there, and we have like a bash script to simulate what's going to land in Spring Boot. And just because like colleagues like to make fun of us, they actually merged the fix today, like an hour ago.
So we could have done that with snapshots, but no.
Yeah, no, we're not going to do that. Okay, so let's maybe start the service here because we're going to show you things outside of the IDE. Okay, so I have my app running. The app has been built, I believe. Yep.
So we're building the regular fat jar for Spring Boot with all dependencies included, right?
Mm-hmm. So the regular thing that you know, java-jar, the application is starting, something like 1.7 seconds, more or less. So what we want to show you is some tips and tricks that you can apply to boost that a bit. And also some shiny things we are currently working on. One thing is you can get a little boost by actually unpacking the application jar and not using the bootloader. So essentially like extract the content of the application jar and run that in an exploded fashion. So let's do that.
Yeah. So it's usually what you want to do if you ship your application as a Docker container. Usually you want to do this and have for several reasons. One, for space efficiency, because it will store your application as layers, and those that are updated more often, they'll be overwritten and not the ones that are quite stable. And also for like Stéphane said, for performance reasons, because startup is better, and because serving resources as well from an exploded application is way faster. So accessing the class path in an exploded fashion is better. So doing that in all cases is better.
Ooh. What? Oh, okay.
So you need Java 21.
Yeah, that doesn't change, of course. So the app starts in 1.3 now, out of 1.7. So you get a small performance boost that actually quite good already for this small app. But you can go further. And actually the little script here that we use for demos is telling you as much. Who heard about AppCDS? Okay. Really not a lot.
Yeah.
Although I can't see anything, so I'm just like guessing. So AppCDS was available since Java 9, so it's not like something that's really new. Initially, they made it so that to share the cost of loading classes amongst multiple processes. So you essentially have a cache of classes, and when you start the same app multiple times, you don't pay the cost of basically filling the permission space multiple times for the same thing. And over time, they've actually evolved to single process, single app model. They've improved CDS in that area, in that target. And I want to say in Java 21, the difference between 17 and 21 are really important. So don't make the mistake of playing with this with 17, saying this is it. There is really a lot of improvement in 21. So the way this works is, and it's integrated in Spring Framework, which is also why we're showing you this. The way this works is it's essentially doing something in 2 steps. You do first what we call a training run, where you start the app up to a point where it's ready to service request or about to finish the life cycle of the application context, and then we stop it. So that's where the Spring integration comes from. We don't go too far into the service startup. And as you've seen, I was a bit fast here, but there's also a property. Oh, wow, okay. From my shell then.
Spring.context.
Yeah. There's that's the property from Spring to actually do what I've just described. The other one is making sure to save the state of the class cache to a file, which is application.gsa. You can see here it has been created. And the next step, of course, is whenever you start the same app, rather than just starting without an extra flag that uses CDS, you point to the application cache.
Yeah, but very quickly it comes with like different constraints, and it's a different model than other solutions to have super fast startup. Here, the constraints are you need a very stable class path. You can't just drop an agent or whatever, because it might work, but you won't get the same results. Here we're basically shaved off 50%, which is not bad for our case. You also need to use the exact same JVM version.
Yep.
So don't build locally and have something else done on the CI, or something on the CI and another JVM in production. That's why it's friendly for containers. And the other constraint is this is shaving off startup time, but it's not doing like warm up. It's not doing tree shaking, so the app, the memory won't change at all. So it's not optimizing for optimized performance right at startup, so it won't be warm right away. So it's just about shaving off a bit of startup, but it can be useful for your application.
And the Java platform team at Oracle is still working on this. So they're working on Project Layden, if you haven't heard of that, which is like taking CDS to the next level and caching more things and more performance improvements. So something also to consider for your next hacking session.
And we're on time. Thanks very much. And don't hesitate to ask us questions after the talk in the halls. We're right there. Thanks.
Thank you.